We were presented with a challenge. We had a client call the other day and they said, hey, I've got some parts, I'm interested in your 22 IDEX. And we said, great, what are you printing? He's like, well, we do a lot of ABS parts, but they're really big parts, and our bamboos and small printers and all this stuff, they just can't handle it because they don't have heated chambers and the parts warp out of control, and so you just can't get these parts out. And we said, well, that's what our machine is designed for. We can definitely do huge parts in ABS, polycarbonate, nylon, you name it. He said, all right, well, I'd like to see that. Can you guys print me a sample? And we said, tell you what, I'll do you one better. Send us the part, we'll print it, and we'll make an entire video on it and send you that. How's that sound? He said, great, if you can do that, I'll buy a machine. So here we are today, and we're gonna show you exactly how we did this whole part and how we optimized it for printing quality and to use a larger nozzle, massive layer heights to get the part out much, much faster than with your standard setup. So here I have a bunch of parts. Let's dive right in. All right, so these are all in order, and I'm gonna show you on screen. We have our spreadsheet of settings so that we record and document everything we change throughout the process, partly so that we can go back and reference that, or we can also share it with you guys. So this is the first part we printed. As you can see with this part, there are some issues on this top layer, this top surface here. There's some gaps and some stuff, so let's look at the settings. We were at a 10 on volumetric flow rate, and the pressure advance of 0.035. So the volumetric flow was lower than we could go. So for the next part, he made 3 little changes. First, he did the volumetric flow up to 18 from 10. So that's gonna increase the amount of just the speed that it can go and extrude per second, basically. As opposed to saying, go faster, it's like extrude volumetrically more, which is automatically gonna increase the speed. He also changed the pressure advance, took that down from 0.035 to 0.015, just those 2 changes. And it looks like we got much better bottom layer there. As you can see, those thick lines, but probably still a little bit much. But the main thing that happened after this was you can actually see the bottom of the part. Now, as we go through the settings, you can see here, that first layer is not quite perfect. There's a little bit of gaps. So then Manny was like, I am going to go tune in the entire mesh leveling and make sure that that is good. And so he just printed the whole first layer, the entire part, and got this, which offhand looks okay, but then you realize none of these layers are connected. This is almost like fabric or something. You can see right through it. So clearly not acceptable, but it's also a little closer on that end and a little bit further on this end. So he did some adjustments and changed some offsets with the nozzles and placement and all that, and did it again to get this, which is a beautiful first layer and half of a second layer. So you can look at the very bottom and you can just look at all the lines and see how connected or unconnected they are. So we dialed that in, said that was acceptable, and moved back along to the next part, which is this entire corner. So with the new settings here, you can see we still got the similar filled in top surface of this second part. So this second part carried the settings over. He did make a couple more adjustments, taking pressure advance down to 0 and increasing the infill overlap. The infill overlap is how far the infill goes over the perimeter walls, so you have a really strong, solid connection on those areas. Infill overlap went up to 40%, and then he also changed the infill pattern to Hilbert curve. Hilbert curve's an interesting one. Depending on your part and the structural considerations for its application, Hilbert curve uses a bunch of like sort of swirly, zigzag sort of things, which means you have corners everywhere, which means there's not nearly as much long chain warping. When you do a long extrusion and then you come around, then at those edges, that entire polymer chain is gonna increase to the warping forces. Whereas if you have a bunch of stuff just going around in random directions, there's no one angle that's pulling up. So that can help assist with warping in certain parts. So we changed that and we got this part, which is beautiful. Just testing the corner, testing these little overhangs, making sure everything's looking beautiful, making sure it's looking good. So next was part number 4. On this one, they went up in volumetric flow again, up to 20, just try and push the limits there. and turned, let's see, the fan was still off. They took the infill overlap back down to 25 because it was working fine at 25. And they changed the infill percentage to 10%. So looks like they printed it. It looks pretty good, but there were certain things that were noticed, such as here, you're getting a little bit of drooping on that overhang. And then up here, you're getting some warping. And it looks along this whole line here, it looks like overheating. So after that, they turned on the fan. So revision 5, they went down a little bit in volumetric flow because we were pushing a lot more filament, a lot more plastic, and turned on the fan. So that resulted in this, Rev 5A. So here, on this part, we can see there is some weird stuff going on out here, but overall, the rest of the part is looking good. So on 5B, he took it and extended it and just did that entire side of the part to see how more features of it would turn out, especially this inner area with all that, all that top layer. And this one's also looking very good. And the only difference here was he went back up on the infill overlap to 50%. Overall, looked very good. So we're like, all right, now let's try printing the full L shape of the X and the Y along with the vertical. Let's print a vertical section to make sure this is gonna work out good. But we had a thing, this giant spool, it's not that huge, but it's a 4 kilo spool. So this is 4 kilograms of ABS, but we were running low. We didn't have enough left. And so we had to calculate how much filament do we have, and we need to slice this part to run a large test within the parameters of how much filament we have left. We cut the part up, and it resulted in this. Now, as you can tell, this is not a successful part. There's stuff going on, obviously, down here. This whole area is all kinds of messed up, and then up at the top here, you can see all of this is just very, 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 very messy. Now, coming in and seeing this, we're like, how did it completely fail on the bottom area and then still print this whole thing? So we took a look at the time lapse to see exactly what happened. Let's roll that now. I have never seen anything like this. I am so fascinated and amazed that this even continued printing with the amount of actuation going back and forth. I'm flabbergasted that this part even finished. Absolutely crazy, but it makes a lot of sense why this looks all nuts up here. It's absolutely crazy. So we're like, why did this happen? And it was we weren't looking close enough when we sliced the part. So this area over here is supported by the bottom layers, but this one over here, we cut a little bit too close, and there was just no material. There was literally no material connecting this outer part to the base. So this started printing in air at the beginning, and there was a bunch of warping and whatnot like that. And what we've determined happened was this little section was warping up, the nozzle came back, hit it, skipped steps, and kept going and just kept printing the part, and got past the warping because the heated chamber helps a lot with that warping, so there's not nearly as much, and it just kept going and then finished the part. But by the time it came up here, it was dragging, and it literally just crazy, absolutely crazy. So we came into that in the morning and we were like, oh dear Lord, what happened? Let's fix this. But that was also the last of our filament in this material from 3DX Tech. So we were like, well, we got to go get more material and move on to the next test. At some point, I forgot to mention, we wanted to test the Z to see how high it would print, and we got this right before we ran out of this dark gray filament. So just to show you this real quick, this is a flat ABS. I mean, this is a flat model. This 3D model does not have any curves in it. But as you can see, the edges, all the flat surfaces are very, very curved. Now, why is that? Even in a heated chamber, this thin wall of ABS still warped because there's just not enough structural integrity to keep it nice and rigid, and so the whole thing just has this crazy warpy texture. Kind of cool. Anyway, new trash can. So we got the new filament, and we started testing that out. So the first print in the new filament, you got to do some of the same stuff, make sure the filament, different filaments from different manufacturers or even different colors from the same manufacturer will print differently. There's different pigments used, like white material generally has titanium dioxide, which is actually getting replaced now because we know titanium dioxide is not very healthy. It's also very abrasive, so you'll wear out your nozzles on white filament, which is fascinating. Not to mention glow in the dark or other pigment colors, and not even getting close to carbon or glass fiber. That stuff will eat right through your nozzles. So always be aware, even if you're using the same filament, if you're switching colors, or on the consumer market, there's a lot of like the silk PLAs and these different ones, or the tough PLAs, and they all print differently a little bit. PLA is incredibly forgiving, so try not to compare PLA to too much. It's just a different animal. But always remember what's actually in your polymer, which is why I love using just natural, just unfilled polymers, natural regular nylon, regular polycarbonate, or your Ultims, etc. I just prefer that, but a lot of times like the aerospace guys do need black Ultim 8085, or some of the flight ready parts or the flight safety parts that have to be embedded in red. There's applications for it, but I always recommend going with the most natural version of the polymer. Now, on this one, we went with light gray because we can. So, let's see. So this is Rev 7. So Rev 7, again, not much changed from the last one. In fact, I don't think anything at all changed, and it came out pretty darn well. So we were like, great, let's do a little bit bigger part. This is Rev 8, where again, nothing changed, but it came out really nice. And so we said, all right, let's do a bigger part. And this is where stuff got interesting. On Rev 9, it had a couple things going on with it. Number one, we noticed it was overheating here on these areas. If you look, you can kind of see it's all wavy and stuff. So it's a little bit too hot. So there's a little bit of overheating. There's a little bit of other stuff going on. If we look at the bottom layer, we switched over to a different machine, and the bottom layer is not quite perfect. I don't know if you can see in the video here, but this side is a hair higher off the plate than this side, so you can see a little bit of gaps. Hear that? You can hear that. Versus, so we're like, back to the drawing board, or back to the calibration, and let's just dial in our first layer, which he did, resulting in this beautiful first layer. And just looking at this is incredible. I mean, this is a ridiculously good first layer. Perfect across the board, and you can tell it took him a lot to get it off of that plate as it's all warped like that. And I think he took it off while it was hot as well. So just something to keep in mind. And then there's another interesting thing that happened on this part. We probably would have let this go and called it good. It's just a big bin. It's ABS. It doesn't need to be pretty, the inside. It's gonna hold scrap metal, it doesn't need to be anything beautiful. But, we always like to have high standards for everything that we do in the shop and send out in the shop. So we do a decent amount of printing on large spools like this, but these don't fit inside the chamber. So you have to feed it from outside the machine. Now, we've had this in mind since V1. We ran into a new problem that we'd never seen before, and that was that when you're running large spools like this, then you can't fit this inside the chamber unless you're doing really short parts and you put it in the actual chamber on the bottom of the machine. But if you're doing a full chamber, you can't fit anything down there. So we had to run it outside the machine. Now on this part, we said, all right, we'll just unplug that thing from the back and just run it up into it, good to go. But this filament, going around the curves of the PTFE tubing to the hot end, there was just barely too much friction. There was just enough there that it started pulling on the actual PTFE, and it pulled the PTFE out of the machine a bit and then cut on the actual filament spool to where the extruder couldn't pull the filament anymore, and it just jammed and started air print. It didn't jam, it just stopped printing. It was total under extrusion. And so we were like, perfect chance to design a new part that'll prevent that from ever happening again. So this is a custom part that you can download from the wiki.visionminer.com, where we have all our support for the 22 IDEX, as well as some other products. And this part's available up there. So if you are doing large format large spool printing. This is an extra safety feature just to secure the end of the PTFE tube so that it can't be pulled away from the machine and cause any sort of problems. So we ended up implementing this immediately. And then we've got the full print. But that print is still in the back. So let's see what they changed before going on to Rev 10A, 10B, and 10 Final. Let's check this out. The last three, they went on the chamber from 70 to 80 at Nazar's suggestion. Hey, it's not gonna hurt. ABS likes those warm temperatures. Give it all you got, and it'll sort of anneal it while it's in the chamber too. So we upped that. The volumetric flow actually went down just to slow things down a little bit. It'll give the part a little more time to cool, less cooling fan needed. They also went from 3 to 2 perimeters to lower the thermal mass, just so it wouldn't overheat as much. You wouldn't see those melty areas. And it looks like they changed the bridge flow ratio on the very last rendition to 0.4. So we'll actually see how well that worked, if there's any noticeable changes, as well as the extrusion multiplier. The extrusion multiplier was upped to 1.08. Now, it's funny to me because there was no testing done on this, no small parts, no nothing. We just sent it, just full send, let's do it. It was the weekend, it's gonna take 3.5 days. Hit it, let's go. We got spare filament, we'll figure it out if it doesn't work, but we're confident. So we did it, and the infill was also increased to 15%, as well as the infill pattern was changed from line to rectilinear. Earlier it was Hilbert curve just for one revision. Not really necessary. That Hilbert curve technique really comes into play like Peak and Ultim and the extreme warping thermoplastics. So at this point, we're ready to get the full part out and see how it turned out. So let's do that. All right, so I've got a couple tools to remove the part. First one is gloves. I'm gonna reach in there and unscrew the thumb screws, and they're hot because the machine's still hot. So always wanna wear protective apparatus to not get burned. The next thing I have here is a ice pack. Now, Alonzo's out of town for the last day on vacation in Boston, so his ice pack from the freezer is acting like our cold shop concrete floor. Basically what happens is, when you use the nanopolymer adhesive for any of these materials, it works incredibly well keeping them stuck to the plate. It's activated at temperature, so really above 60 Celsius or so. So if you can drop the plate down below that, the adhesive deactivates and the part pops itself off. So we're gonna use this ice pack to rapidly cool that plate down, and then if I need it, I've got a traditional scraper tool. So let's go ahead and get it off the plate. I'm just gonna open up the door here, reach behind the part, grab this rear thumb screw, just loosen it, I don't have to take them off all the way, and then the front screws, and we can slide out our plate. Woohoo, look at this thing. Oh my gosh, this is heavy. All right, go ahead and close the door to maintain the heat. And, oh guys, look at this. Oh, this is huge. I'm gonna just set it right there on the ice pack and just start rotating it, taking that heat out. Cole, what do you think? Come check it out. Woo!
That is large.
So the guys from PCP Aluminum, this is the test part. I'm guessing it's just some kind of scrap bin for metal shavings or something. I'm not entirely sure. It does have drainage. You know what? Dude, this is a planter pot. It's got little holes in the bottom.
What's this? That's weird.
Oh, interesting, yeah. So it's got this tray at the bottom, and it's got little holes down there. So this is like, you could plant a freaking tree in this or something like that.
Or a plant.
Or metal scraps, you know, whatever you want, really. That's the 3D printing. You can make whatever you want for whatever you want.
Dreams.
This might be a hammer job. So I'm gonna give it a little bend. Oh, you hear that?
It's not.
Again, just using the ice pack as a fulcrum. Oh, yeah. Right.
My back hurts just listening to that.
Oh, and you don't want to go too fast. I have had the bottoms of parts rip off, so I want to take my time with this, just give it little bends. Cole, you've always been a fan of printing with a 0.8 nozzle.
Yeah, even bigger.
What kind of stuff have you printed over the years?
Vases.
Very clear, very thick, very
Very
strong.
thick vases. Tell me NPA doesn't work.
Yeah.
Look at me in the eyes and tell me NPA doesn't work.
Available at visionminer.com/adhesive. Oh god. Did I mention we have 3D scanners? We have an entire line of metrology grade and reverse engineering grade 3D scanners for professional use. Ugh. We do those videos too. Check out, subscribe. Oh yeah! Oh no! This is why, guys, patience is a virtue, especially with 3D printers. So be more patient than me on video. What did happen here? Let's look at that. There's warping in this corner.
Yeah.
Now I'm guessing this is gonna be the back left of the machine, which suggests that there's more heat back there, which makes sense because there's a heater in the back left of the machine. Very nice. Dude, all right, so let's see. Manny, how many grams of filament did the slicer say was going to be in this part?
3,268.
3,268 grams.
Kilos.
Let's test that. Where are we at?
3114.
3114. It's less.
Yeah.
Why?
Well, was the density of the material put into?
1.04.
Yeah, I think that's right.
Good times. Well, unfortunately, we had some audio issues here, but we did reprint the entire part to get that perfect bottom surface finish and changed a few other settings just to make it really nice and fresh. And here are the results. All right, so immediately between the two, you'll notice that's the first top surface. That's the next top surface. It's much smoother. Overall on the inside, I'm not noticing too much more. The overhangs are similar. It's a little bit cleaner, but that's about it.
Let's see.
Yeah, I'm gonna give it a bend. Well, that was easy.
Yeah, that works.
That was a lot easier. Beautiful. I want to show you guys a secret little trick in here. Texture coming on the bottom of ABS parts. We can get rid of all of that with a quick propane torch. Beautiful. All right, what are we at? Awesome. All right, so that is that. Printing a giant ABS part on the 22 IDEX V3. If you want to know more, you're printing stuff like this, or you want a consult on, hey, what printer should I actually buy for my business? This is what I'm trying to do. We're here to help you answer those questions. We've got a lineup of our own printers, but if we don't have what you actually need, we'll tell you that too. Our biggest thing is just getting people what they need at a great price. We want to see everybody creating their products and additives, saving money, saving time, and driving this whole industry forward. So on that note, thank you guys so much for watching. Hit subscribe if you want more. Leave a comment on what you want us to do next or what you liked about this, and we'll do more of it. But on that note,
see you next time.
have a positive rest of your day.